Hello and welcome to I guess a bit of a trip down memory lane, really, here at Underware Design. I want to have a quick look at some old programs, things that were kind of weird sort of ideas and test programs and things like that. We can find them over here under the programs label on our old website. You might have realised I'm not a big fan on big flashy websites. I like it to be simple. That's how I like it. So if we go into tech demos and discontinued programs down here, there's two things here. There's a thing called Kyruss and a thing called Kyruss 2, which is I guess we might talk about another day, or maybe today. Kyruss is it's a virtual machine where you program. Well, it was going to be for kind of virus battling. So you would sort of write these bits of code that would sort of attack each other and try and be the one to survive. And it was an idea that a friend of mine came up, or myself and a friend of mine came up with. The guy's name was Daniel Martin, and this was outside the Battleground users group. A long time. Sorry, Amiga users group. Shows how long ago that was. I'm not quite sure when this was. I think it was probably 93 or something like that. 94 maybe. Don't know. And so the concept behind this, which look at the image, like it's not pretty to look at. But what this thing does is it has an emulated environment, a virtual machine, and the virtual machine has a simple CPU representation, a small memory representation, and kind of an API to draw things like, as you can see here, we're drawing lines and boxes and this kind of material here. You can do some text things and stuff like that as well. But what you write the programs in is something that's not too far away from 68,000 assembly. So that's what I wanted to look at. For people who are curious about doing some assembly, this might be a place to start, even though it's kind of a quirky, weird idea. So to download it, grab the top version, that's the newest one, save file, and you just get a zip file. Now I've already downloaded this and unzipped it for us, and it's called Kyruss Demo. Inside the archive, we've got nothing more than, well, as you can see, we've got nothing really there. The executable, Kyruss folder, some graphics for the program itself, and the documentation. When was this written? Okay, this was built 21st of July 2007, so that's almost 10 years ago. And this version here is written in a very early version of PlayBASIC, which is the language that we sort of wrote. Let's write it. Yeah, it's not very exciting to watch, and I think it has a fixed screen resolution. Yeah, it does. So this is the boot up screen, gives you a bit of information about what it has in it, and you just press space to run. So what we're looking at is its concept of a desktop. These are programs that you can compile and run, and to do that you just double click on it. Probably not even double click actually. This is the assembler output, and it shows you that, so if you make a mistake or whatever, you can go back and change it. It's got a simple Windows emulation. See some of the code passing through there, drawing some lines. Bring 2-day stars back. The virtual machine has a concept of time sharing, so the VM will execute each process for a limited number of cycles and then switch to another process. Each process has its own concept of screen, so you can't draw outside of these windows, for example. You don't really have any access to the actual display data. You can't really do anything outside of the VM at all, to be honest. What else we got? Text scroller. Scrolling some text. 3D stars. Where is the cube one? The box one. Ah, wireframes. That'd be the one. This is actually a 3D scene. Now you might notice that while the compiler is going, the rest of this keeps going as well. It's not, the VM isn't threaded, it's just slicing the time the assembler is allowed to use and the VM is allowed to use together. So as you run more things, the whole thing gets slower, which is pretty much the way your computer works anyway. Sometimes we kind of don't realize what's actually happening, that many applications we're running are sitting there doing nothing. They're waiting for input. So we've got this wireframe demo. I can run that again, by the way. So it shows you the address it loaded into in memory. I think that's where it is. I'm not actually sure now. All of the processors share the one space in memory. There's no memory protection. That's what the idea was, that you would kind of make these little viruses and you would run them in the virtual machine and see who could win. And people, you mentioned sort of viruses, and people don't really like the idea of that. That's why it's kind of a discontinued concept. It's really just an assembly tutor now. That's all it is. These are two separate instances of that program running. So I can run it again. I don't remember how much memory this thing actually allows for programs to be in, but I don't think it's a whole heap. So just close one to get rid of it. Obviously, the more of these you close, the faster they're going to execute. Yeah, it's a lot easier for the VM to run that when it's not doing anything else. Now, these programs themselves are just text files. They're stored over here in this Kyruss folder. Go inside there. Sorry, I'll just pull that across there so we can actually see what's going on. I might do it the other way around. Feels unnatural to have that on the other side. How dare I? So these are just text files. What's one we're looking at? Wireframes. Sorry, it's covering up the whole screen there. These programs have a certain structure to them. There's probably some way of stopping that, but I really dislike that about modern versions of Windows. That drive me nuts. Programs have some constants you should set. So you're just saying the name of your application. That's what it appears up in here. Who wrote it? How many bytes your program's going to take, and because all these things are assembled flat, so all the data is assembled just in one chunk. So code, variables, all exist in the one space. Anyone who's had a bit of a look at 68,000 programming will kind of recognize most of this, but it's kind of simplified down from that again. When our application starts, we can do things like we can call functions that are built into the VM to get information about. In this case, we're calling get window size. So it gets the size of our window that our process has and returns the width and height in D0 and D1, storing those in a couple of variables down the bottom here somewhere. Probably should have looked at it much simpler. There it is. Probably should look at a simpler one in the middle. So we're doing an LSR, which is actually just dividing those two in half to get the center position, storing those in center X, center Y down here. we're telling the VM to let us control when the back and front buffers are flipped, which is so this window is double buffered. If it wasn't, you would see it flicker and flash. You'll see it slow down, but you won't see it. Otherwise, you would see it manually redraw the screen, which is very ugly. Got a CLS call. We're getting the address of our rotation angles, which will be stored down there lower somewhere. And these are offsets. There would be some constant definitions that we're using. There it is. Think of them like structures in normal programming. So A6 is the base pointer, and these are fields within offsets or fields from it. So it grabs the data where A6 points to and adds on whatever this offset here is to find the actual byte, or the long in this case. I think one of the differences between how this works and how real 68000 works is in this there's no real concept of byte, word, or long. I think everything's just longs. But don't quote me on that. It's been a while since I looked at the demo. Got some code to do some rotation, and if I actually think that's probably my old rotation code from way back in my Amiga days. I wouldn't be surprised if I just cut and pasted that across and tweaked it up to run in here. It's not great, but that's the way it goes. Drawing our wireframes. So as you can see, this is what assembly programmers really like. To make even something this simple, you need a bit of effort to do this. Got some cosine tables, sine tables at the bottom. They would definitely be from my Amiga days. I might have generated them again, but I somehow doubt that actually. Okay, so that's one of the more complicated examples. Let's have a look at a simpler one. What about sticks? So, 3 constant set at the top. Our program size is 250 bytes. I've got a width and height variable, which I have no idea what they refer to. Okay, so we've got a structure here. We're getting the address of this, and then storing our width and height in there, just to be. So that down here we've got the two variables side by side. So the x and y coordinate, we don't have variables directly. We just have this screen, this window size structure. Yep, this is our main loop, I would say. We're generating a random ink color by randomizing these fields, and okay, drawing our line. Alright, so we're getting the width and height of the screen. We're using them as randoms. This would randomize D0, so it's a value inside the screen coordinates, or its width coordinates. And this would do the same for the y coordinate. The other xy coordinate then draws a line. A1 to our sticks counter. Okay, so it's drawing 100 lines and then clearing the screen and just keeps doing that over and over. Let's have a look at that running. Sorry, where is it? Sticks. Yeah, there you can see. We just get coloured lines all over the place. It just keeps doing that over and over and over. It's the same program running, but they are 2 different instances of that program running. 3 different instances. So if we edited this just for the sake of example, let's do a move. Let's set the red component, which I'm guessing here is D0. to that. So we'll nullify this random. We don't need that random. If we do it again, now they should be always red. So this is the high bit of the the high byte of the RGB is set to that. If we set this in D1 and save it and run it again, yeah, we're getting from yellow to white. If we set these to 0, we just get blue color, shades of blue. Yeah, am I freaking you out so far? Probably, I would say. Let's have a bit of a look over to the help file. So let's get back to here. We'll minimize that. Go up to our document files in here. Just HTML, by the way. I use Firefox, so I'll open it in Firefox. Pretty old. The first version was built in 2005, so it's pretty much 12 years old. This is kind of a, it's the objective of what we want to do, and this is just kind of where it was at the point we gave up on the idea. So in here though, you'll find information about the general information that I went through before. Some information about when releases were built. And then the most important stuff is stuff about the assembler at the bottom. We talk about what the source code is, what are constant declarations, what are labels. Assembly, actually, unlike other languages like BASIC, generally has very strict layout. So, and this is no different. It's certainly not as smart as your average modern assembler now, which can do all kinds of great stuff. This one here is just very simple. That's all you really need to start learning. Go through about the assembler, a bit on, yeah, there's a lot in here to take in if you're new to this stuff. I guess that's the point. So this is the instruction set that's supported, and we're looking at our move instruction here. And then we've got a whole bunch of different variations that we can do. We can have fixed offsets, so we can move from memory. We can move literal values into a register and other places as well. So we've got a fair bit of stuff that's supported. We've got a clear instruction, a compare instruction, test, branch not equal, branch always, branch lower, branch high, BSR, branch not equal. That might be in 68,000, I can't actually remember now, it's been a while. Add, subtract, divide, multiply. All this stuff is integer, by the way. You don't have any fancy things like floating points. So if you want to have that kind of thing, that you need to use fixed point math. And if you're not sure what fixed point math is, well, time to learn it. The API is about the built-in commands you can call. There's a very limited list of them, there's not much you can do. That's kind of the point, really. You can do some. Most of these things are graphical. So, clearing the screen with color, printing a message. So, all that good stuff. Okay, let's go back to our screen. So this is pretty much Kyruss. This is really, I guess now it's an assembly tutor for people. Just stretch the window. The way I would do it if I was you is I would just leave the window running here, and then make a copy of one of these files, copy it here, say. My new demo. I'm just wondering whether it will pick that up again. See if it does. Okay, it does. So it's seen this as a new program. It doesn't know whether it's what it actually is. Oh, that's all it does. That's it there. Of course, what you would do now is you would open this up in text edit and you know, give it your own name. You know, make it 1,000 bytes long. Who knows? Alright, so I was saying the old version of here was doing that. We're getting a random color, getting a random position, and calling dot. What about if we call box? And I would bet that the first two coordinates are the top left-hand coordinate of the box, and they'll be in D0, D1, and these will be in D2, D3. We'll soon find out anyway. There you have it. Some boxes. Now, I know I'm making it look kind of simple, but it isn't much more complicated than that. But you will find that doing very simple things is quite difficult in assembly, and that's why people don't treat assembly as a language that consider assembly. Oh, sorry, I'll get to that. That's why people don't consider assembly a language that programmers should learn anymore, which I think is rubbish. You should learn everything you possibly can, because it's the only way you're going to get anywhere with this stuff. Even if it's just for fun. Hell, you know, I'm not saying become an expert of this thing. No, don't waste your time. But grab it, mess around with it, see what you can come up with. If you make something cool, come on the forum and post it for other people to play around with. You know, share that stuff with other people. Because you'd be amazed to find that there'll be other people sitting out there going, I wouldn't mind doing something with that, but I've got no idea. Oh, there's a Pong example there too. What's that one? What's that one do? There you go. Some bouncing balls. Nice dots, sine waves. Even the sine wave thing there, see I've had to make a sine table because cos and sine are not supported. They're not. So if you want to do those things, you've got to work out a way of doing it yourself, and that's just going back to the old 16-bit days on the Amiga in particular. People look back in those days now and they go, oh gee, how easy it was to make games and those things. But you didn't have floating point. Things that we can do now that are trivial now, where it felt like they were impossible mountains to try and get over. But anyway, I apologise for rambling on so long. Didn't intend on doing that. So that's Kyruss, and you can find Kyruss over here at Underware Design. I know it's not the greatest thing in the world. The other program book that was called Kyruss 2, which is another similar idea. This one here is based around BASIC. So this is kind of a robot game idea, and the bottom shot here was actually, there was one of these. It was we got it to a point where we had a world, we had the basic compiler, the basic runtime working, and you could have a bot moving around in this simple world, but it was pretty slow, and wasn't for lack of wanting to do it. It was just slow. That's all. These are samples of the code. Looks pretty much like PlayBASIC, because pretty much when we sat down to write PlayBASIC, we based it on a variation of that Fraser. It has nothing in common with it today at all, actually, but back then it did. So this was a basic compiler. Yeah, I should really do his own video on that one there. But if you're interested in it, just fire it up, have a look at it. It doesn't work like PB works, for example. This is your standard output window, and it's giving you an overview of what variables you have, and the VM's right here has controls, and this demo here was actually written in PlayBASIC again. So, and this is a very old demo, probably well over 10 years old now. No, sorry, it wouldn't be. If Kyruss 1 was 2005, Kyruss 2 is probably around the next year, 2006, 2007, so it would be on that threshold. But anyway, thanks for indulging me with a bit of retro rubbish, and just wanted to say you can find some weird stuff on our website, and you can find a lot of weird stuff hidden away in our forums if you dare to have a look, particularly old retro kind of things. So drop in one day and say hello. Thanks for watching, and catch you some other time. Bye.